Soon enough, the title of this lecture note will make sense. But first, I want to talk about the word ratio. Ratio is a fraction. It's a comparison of two numbers, two quantities. So let's begin by looking at a street map of the Antelope Valley. And if you're not familiar with this area, this is near the mall in Palmdale. And you'll see that this is the 14 freeway right here. That's a freeway. That's not a street. And then you have 10th Street West going this way. And you have Rancho Vista Boulevard going this way. And ironically, it forms a right triangle. Oh, snap. So we're going to identify three corners here. There's this corner right here. I'm going to label this one C. And this is the Taco Bell corner. We'll call it T for Taco Bell. What the heck. And this is the Verizon corner. I'm going to call it V for Verizon. Okay. We identified the streets. There's this 10th Street West, and then there's Rancho Vista Boulevard. The freeway is not a street, so I'm not identifying that at all. I'm not highlighting it. There's only two streets that make up this triangle. That's 10th Street West and Rancho Vista Boulevard. So let's be realistic here. If I'm standing at the Taco Bell corner, I'm standing right here in the Taco Bell corner, what street am I on? Street. Remember, I'm not on the freeway. The freeway is not a street. What street am I actually on? Well, I'm actually on Rancho Vista Boulevard. Okay. Now, we would say that this is the adjacent street. Adjacent means the street that you're on. Okay. I know I'm standing on the corner, but I am adjacent on this Rancho Vista Boulevard when I'm at this corner. As I'm standing on this corner, and I happen to be in Rancho Vista Boulevard Street, what street can I see from this corner? Well, if I look across, I can see 10th Street West. I can see Carl's Jr., I can see Chili's, I can see Applebee's from this Taco Bell corner. I'm not on that street, but I can see that street. We call this the opposite street. So if I'm standing on this corner, this is the adjacent street. And then this is the opposite street. I'm not standing on the opposite street, but I can see it. Now, all this was true when I stood on the Taco Bell corner. What if instead I stood on the Verizon corner? What street am I on? What is my adjacent street? Again, the 14 freeway is not a street. That's a freeway. Okay, so the only street I'm actually standing on is 10th Street West. That's the street that's adjacent. And if I'm standing on this Verizon corner, what street do I see opposite? What street? I'm not asking what corner. I'm not asking what buildings. I'm not asking about the freeway. I'm asking what street. So when I stand on a corner, I'm talking about streets. So if I stand on the Verizon corner, I am on the 10th Street West street. I'm on that adjacent street. And I can see an opposite street of Rancho Vista Boulevard. I'm not on Rancho Vista Boulevard, but I can see it. It's the opposite street. Recognizing that we're standing on corners and talking about streets is very important to your understanding of trigonometry, which is what we're getting at here. Okay? So we stand on a corner, and then we talk about streets. What street am I on, and what street do I see? And that's pretty much it. That's all of right triangle trigonometry from our perspective. So it is as simple as stand on a corner, tell me what street you're on, adjacent. Tell me what street you see, opposite. The end. Now, let's talk about a dangerous thing. What if I stood on this corner? Corner C. What street am I standing on? That becomes rather confusing because the question is asking which street, not streets, street. And the problem is that there are two that I'm standing on. Okay, so this becomes problematic because I'm not standing on just one street, I'm standing on two streets. That's problematic. Furthermore, when we ask the question, what street do you see across or opposite, right? What is the opposite street? Well, we don't tell me the 14 freeway because the 14 freeway is not a street. So do you see the problems that we run into when we stand on the right angle corner? First, there isn't just one street that I'm on. There's two, and that's problematic. And then the other thing that's problematic is when I look opposite, right? When I'm looking for the opposite street, there isn't an opposite street. There is this freeway, which doesn't make sense with the name of the game. The name of the game is what street am I on? What street do I see? And the problem is it changes the whole game to how many streets am I on? And there is no street across the street. Okay, so what we're saying is we run into multiple complications if we stand on this coffee bean right angle corner, this C corner, right? You're not just on one street, you're on multiple streets. And furthermore, when you look across from that corner, there isn't a street. So I need you to learn right now that we don't do ratios from the right angle. We do it from the acute angles. That would be from this corner and from this corner. We don't do it from this corner. Okay? Well, snap diggity. So what is a ratio? A ratio is a comparison of two quantities that is usually expressed as a fraction. And we're going to be making comparisons with, for example, the opposite street to the adjacent street. We might compare the adjacent street to the opposite street. For part B, let's see. So these are examples of ratios right here. Here's 4/3 and 3/4. And let's see what the differences are. So if I go ahead and do 4 divided by 3, 4 divided by 3, I get 1.333. If I do 3 divided by 4, I get 0.75. So they have a different value. So notice they are the same numbers, right? There's a 4 and there's a 3. But how they compare will give you different answers. So even though we have two ratios and they both have the same numbers, the order in which the numbers come and the order in which they're typed in is very important to get the correct answers. For part C, let's go back to the map. We want to pick the Taco Bell corner, and we want to write a ratio comparing the opposite to the adjacent. So first we pick a corner. I'm picking this corner. This is the Taco Bell corner. And I'm writing a ratio, so I automatically make a fraction. And when I stand on a corner, I'm comparing streets only. I'm not comparing corners or freeways. I'm comparing streets. So if I'm standing on this corner, what is the opposite street that I see? Well, I see 10th Street West. What street am I on? What is the adjacent street that I'm on? Rancho Vista. So this is the ratio. And you're thinking, where's the math? There isn't right now. We're just showing you how to set things up. This is the comparison of opposite over adjacent from the Taco Bell corner. Part D, this time let's pick the Verizon corner and write a comparison of the opposite over the adjacent. So this time I'm on the Verizon corner. So I'm going to identify the corner I'm on. We always stand on the corner first. Let's pick a corner, stand on the corner, and then we're going to decide, okay, what do we see, right? So opposite, it's asking for the opposite. It's asking for the opposite street. So what's the opposite street? What street do I see from this corner? I see this street right here. And it's asking us to compare it to the adjacent street. Well, what street? That adjacent means the street that you're on. So if I'm on this corner, what street am I on? And so if I'm standing on the Verizon corner, the opposite is Rancho Vista and the adjacent is 10th Street. So this is the ratio that I can form if I stand on the Verizon corner. Once again, we haven't done any math in the last 9 minutes. We are just making comparisons and setting up ratios. This is crucial to you being successful with the next few videos. So make sure that you know how to pick a corner, right? We're picking an acute corner, by the way. We're not picking a right angle. And then be able to identify opposite streets and adjacent streets. For your summary, when writing ratios in problem 2 for parts C and D, why were the ratios not the same? Use some words.